All right, so in this video, I'm going to try to give you 15 years of knowledge in one video as to why I've moved from Azure to CloudFlare. I'm going to try to give you a comparison, a real world comparison of the breakdown between Azure and CloudFlare. I'm going to tell you where Azure really shines. I'm going to also try to tell you where CloudFlare really shines. I'm going to give you an overview of why I'm choosing to push all of my workloads into CloudFlare of recent. Hint has to do with AI. And I'm also going to try and give you sort of an overview so that you can make an informed decision as to whether you should choose Azure or you should choose CloudFlare. Now, this is kind of a deep dive, so we're going to go a little technical in this video, but I'm going to try to talk to both entrepreneurs, business people, as well as developers. If you're an entrepreneur, great. If you're a developer, fantastic. If you're an architect, even better. If you're a technical founder, even better. So my goal in this video is really just to outline everything. I mean everything. I'm going to try my best to sort of keep this sort of on track. There's going to be lots of chapters. Feel free to skip around for the parts that you care about and the parts that you don't care about. It's just to like offset a series of knowledge about a whole bunch of stuff that I've learned in basically 15 years time frame, compress it into a video that you could then use as a reference point to make more informed decision. I have one philosophy in life, and that is if one person could learn from my mistakes and not do half of the sort of mistakes that I made in my own life, that's a win for me. So that's what this video is about. So it's going to be raw. It's going to be deep. I'm going to try to go as deep as possible. I got tons of notes here. We're just going to go deep. Okay. So buckle up if you're interested in this type of stuff. Now, that being said, if you're interested in more videos like this or you got any questions, feel free to message me. Any feedback is important. And also, if you're getting value from this, don't subscribe until you actually get value. And if you do get value from it, please subscribe and give me some feedback so at least I know that this type of content is important or valuable to you. Okay, I got lots of notes. It's all spread out here and we're just going to go hard on this topic. So let's start from the beginning. I want to kind of set the stage as to what we're going to cover. I want to kind of give you sort of a background of my journey so that you can use that as a reference point before you get too deep in this video. So first of all, let's talk about my background. I've been a .NET developer for over 20 years. I have extensive experience in both building small applications for startup and working for larger companies doing bigger complex applications altogether. I'm an entrepreneur. I'm a developer. I'm both technical and a business person at the same time. So with that, I've been a diehard Azure fan. Now, I will say I've used AWS and I've also used Google Cloud. So I do have experience with those, but the bulk of my experience comes with Azure because I just like it better. That's just basically the truth. In this video, I will make reference to AWS and Google. So at least you have, if you're coming from an AWS world or a Google world, you can use this video as a reference, but I'm going to predominantly talk about Azure because that is essentially the core of my real experience. Okay. And then obviously CloudFlare. The other thing is, this video is a follow-up to my previous video, why CloudFlare is the future. So if you haven't watched that video, I'd recommend that you actually watch that video because I'm not going to talk so much about the why in this video with CloudFlare. I'm just going to talk about the what and the how. In other words, the technology part of CloudFlare, and I'm going to compare head to head between Azure and CloudFlare. So hopefully that's giving you some context into what this video is about. And like I said, if you find value in it or you're interested in more content like this, feel free to subscribe to this channel and let's just jump right into it. Okay, so like I said, first of all, I'm a .NET developer. And because of that, I spent a lot of time learning all of the traditional ways of building applications. And that means we built a web application. We had a database server. We had IIS at the time, Internet Information Services, I think is what it's called. I don't remember now. And we had our application and our database on one server and we were storing files on one server. And that's how we built an application. And that worked for a while. And the reason why we started that way is because we had one client, a really big client for me at the time, that was basically paying me to build a custom application. Okay. We're going to talk about that application a little bit later on, but I just want to sort of set the stage as to that you understand sort of where this journey for me started out. And this was a long time back. It was like 2012. So with that, we built out an application for this client and that became sort of the foundation. Now the problem that we ran into right off the top was the client was growing at a fairly fast pace. And so as a result, we kept having to like make changes to the application and try to keep up with sort of the growing pains of building a brand new application, servicing a customer, and having that customer grow at a fairly fast pace. And just to give some rough numbers, I think when we started with them, they were about $250K in monthly recurring revenue. And when we left that, ended our sort of relationship with that client, for multiple other reasons, which I won't get into here, relationship became toxic, etc. They were somewhere around the avenue of about 1.5 to 2 million in monthly recurring revenue. So they scaled, and that was a course of over about 4 years or so. So they really jumped up, and there was a lot of growing pain. So that's kind of like the birth of, I would say, my journey into cloud, because cloud was kind of going online around that time. And so there was a lot of iterations of just learning as a cloud was just learning also, because everybody, like I remember the clear conversation of like, you're not in cloud, and everybody should go to cloud. And the conversation, just like how we're having a conversation about AI today, back then it was about you should be in your cloud. You should move your workload to the cloud. And AWS was clearly ahead of the game at the time. Microsoft was playing catch up at that time. And Microsoft had one very specific appeal that appealed to us at the time, which was you can lift and shift. That was the word that they were using at the time to describe it. You can lift and shift your workload, because we had servers and we could just lift that up and just shift it over to Azure and put it in their cloud. And that was the appeal from day one for us. And that's the reason why we started sort of going down the Azure path. Over time, that just got a little bit more involved. So let me just show you from a diagram standpoint what I mean with that. So we had a very traditional application, okay? This was a .NET application, and it was an MVC application. And for the most part, basically the website was on the same server, and it was basically the database on the same server. So there was a database here, and we were actually doing local storage for a while, and then eventually we actually moved that over to blob storage. But blob storage wasn't what it was today. So that was it. However, over time, what ended up happening was the load kind of got a little bit too much for this server. And so once that started happening, the first thing that we did was we moved the database, because Azure just started putting a cloud database offering. And so we're definitely early in moving our actual database to Azure SQL. I think back then we were using like SQL 2008 or something like that. And then we moved up to 2012. That was the last database that I've ever actually hosted on my own. So just to give you an idea of how long ago we're talking about here, okay? So when we moved over to Azure database, that was great because we didn't have to deal with it. However, the first thing, this is one of the first problems that we ran into, and I want to talk about this sort of in sequence so you can understand how I've transitioned to where I am with CloudFlare today and why this is relevant. One of the first problems that we ran into altogether is that they had a problem where there was a ID. I remember this specifically because every record that came into our database, as anybody that's done with SQL know, will get an incremental ID. So in other words, customer 1 will get customer 1, and then the next record will get customer 2 and 3, etc. And I remember specifically in the early days, what would happen is that we would have an ID number, and this is our ignorance at the time, and we've never had this problem locally, by the way. And then what would happen is it would skip from 3 and it would jump to, let's say, 6 as an example. This was a real thing that happened to us in the early days, and we couldn't figure out why this was happening. Anyway, long story short, we ended up finding out that the way how Azure was working in the background, it was basically kind of load balancing. And if the server actually went down, the increment from this number and this number, let's say we stopped at this number, ended at 3, the thing, and then the system spun up and it went to this database, it would automatically skip a few numbers and jump to like 6 or 7 or something like that. And I think that was so that they didn't have conflicts. That was kind of a deliberate choice. This created a lot of problems for us. Why? Because at the time, the system was dealing with work orders, and those work orders depended on incremental numbers. And I remember specifically having this really, really big pain point. I think for a good half of a year, maybe even longer than that, we just ran into this problem consistently. And then we had to try and either, if we caught it in time, we would basically change the number and reset the number so that we could get it back to 5 and 4, 5, 6. It just became a real pain point. This is one of the earliest problems that I recognize, that being in the cloud means that you have to think about things differently. And as a result, because you can't guarantee that you're sitting on one single server in the cloud, you have to think about things differently. This was sort of my first introduction to some of the cloud scaling problems that you sort of run into. The next problem that we started running into earlier on was that the server that we started hosting for Azure would suddenly, we had records that would depend on the time for time entry, time logs and whatever. And because we were losing that local server, the local server would, the time, every time Azure restarted the server, it would lose the time that it currently was set at. So in other words, let's say today is October 11th. It's now 7 p.m. 2025. Whenever the server restart for whatever reason, it would then reset it. So it would put it back to maybe GMT time or something like that. And now it would be, instead of it being 7:07 p.m., it might end up being October 12, 1 a.m., which was wrong. And our system depended on that. And so we learned our second lesson around making sure that time is independent of the server. These were some growing pains that at the time, moving to a server platform, these were things that we just didn't have to deal with on a traditional server because of the fact that it was just on and, you know, it was within our control kind of deal. And then came another problem where this came a little bit later on, but it was still relevant, where the issues around time zones became a problem because, again, we were locked into one specific computer. And then we started having customers in other time zones. And we recognized that we can't rely on the time zone for the computer because that computer is in Eastern time and this customer is on the West Coast. So that became a whole lot of problem. Now, once we started understanding that, a couple things started happening. We started running into scaling problems with our computer, with our system. And as a result of that, we started splitting workloads. Now, any architect, any business person that has done any sort of large scale system, you understand this very clearly, right? What I'm trying to do is just basically level set for like a newbie that doesn't necessarily understand this stuff. So the second thing that we started doing is we started sort of load balancing our servers. We migrated our code a little bit more to using Azure Web API as a platform. And we started using Azure Traffic Manager to sort of load balance traffic across our system. Then we moved to Azure Web Apps at the time. So again, still a .NET application at this particular point. Okay. This approach worked fairly well, except there was a problem. Let's say this is a user. They hit the website. Okay. And what would happen is we would get an outage, for instance. Azure Traffic was supposed to, in this particular case, if there's an outage, it was supposed to update its record to notify the service to not send traffic to this server. However, that DNS change took a little bit of time, okay? And what would happen is that DNS change would happen, let's say after about a minute. It was like a 30 seconds to a minute sort of delay. And then it would update. But however, Chrome, the browser, would still cache the DNS. And we were noticing that it would take up to like 4 to 5 minutes on average for Chrome to remove the DNS cache to be able to load the new application. So in other words, it was still sending traffic to the old application. This was a huge problem for us. So as a result, we recognized that Azure Traffic Manager was just not the right solution for us. We also had some print server and we had some storage system, but for the most part, this system that we kind of had in place for load balancing just wasn't working. This was before Azure brought out their front door management system. So let me talk about front door for a second. And again, I'm going to compare all of these solutions to the equivalent in CloudFlare and the equivalent in AWS. What I'm trying to do is just give you some understanding of some of the problems that I ran into as sort of like a new cloud architect, learning about systems and building scalable systems and some of the ways that we kind of started evolving and why CloudFlare is like just a no-brainer for me today. So because we had some problems with our traffic manager system, we started using Front Door. And what Front Door is a way to kind of load balance traffic, but kind of at a global level. So traffic would come in and it would basically sort of split that traffic thing. Front Door was a much faster, much more efficient system. It actually did a pretty good job with it. The issue that we actually ran into with Front Door wasn't so much that it wasn't fast. It was half decent in terms of like being able to switch the traffic. And for those who know, the equivalent for AWS is AWS CloudFront. So I just want to make sure that I got that right. So this is AWS out CloudFront, if you want to call it that. In the Google world, this is Cloud Armor. And essentially what it is, it's just a load balancer at the cloud level. Now, Front Door had one interesting thing. They had a WAF for basically for monitoring traffic that's coming in. It's a security layer. And one of the problems that we ran into was that whenever our traffic came in, legit traffic, not spammy traffic, Front Door would inspect it and they would deem it as sort of like a security risk and they would block it from going to the back end. And we would only find out about this when a customer would call us and tell us that there's a problem. This became a huge problem for us to the point where we had to start routing some traffics outside of Front Door because of this problem. So this is just to give you some ideas of some of the challenges that we had sort of in the very, very early days trying to build up our application. Fast forward a little bit more, and what ended up happening is we ended up with a case where we had to just start building out more and more infrastructure in order to support sort of the entire application. And that sort of transition from just having sort of a basic architecture to having to build out sort of surrounding supporting platforms. We introduced API management layer. This was something that came online later on. In the early days, we actually avoided using this service for multiple reasons. The primary reason was cost. The API management service at the time was a $50 per month or something like that for the basic service. And then it jumped from $50. It jumped from $50 to $750 for some of the more advanced features. And by advanced, they weren't that much more advanced than thing. I think it was like custom domain and a few other things inside of there. So I just felt like it was just insane of a pricing that $750 was a jump from $550 to $750. Later on, they changed this to consumption pricing. And because they changed it to consumption pricing, that's when we jumped on to the Application Insight Manager. The equivalent of that is Cloudflare has a solution called Cloudflare API, which is like the Cloudflare gateway workers. And that's sort of the equivalent of that. Now, I don't have much experience with that service. In fact, we actually still use API management today because it has pretty good integration with things like Logic App, and it has pretty good integration with Azure Functions, and which is something that we still use heavily today. Okay, so I just want to touch on something that's not very obvious as to why we actually moved to Azure Front Door. So one of the problems that we experienced sort of earlier on, Azure has changed quite a bit. There's a lot of growing pains just with Azure as a whole. One of the problems that we actually encountered quite a bit was just outages. It's just Azure was just known for going, and this was a real problem in the early days. So what ended up happening was we would end up having either entire data centers that would go down, availability zones would go down. And this was kind of a problem. So as a result of this, I basically decided that we cannot rely on a single data center for Azure. We just can't. It's unreliable, at least for the type of uptime that we were looking for. And so as a result of that, we wanted to load balance the application across different Azure networks. So East US, West US. The problem with that was that at the time, Azure had no actual solution that could load balance across these different layers, because there's two different types of load balancer. Let me explain what I mean by that. So let's say that you had a server sitting here in West US as an example, okay? And then you had another server, generally speaking, sitting on East US, because this is how we would deploy our service. Azure at the time had no service that could kind of sit here, get traffic sort of coming in, and then load balance between these two servers. It was just impossible, because think of it, this is one data center. Now, that's not to say that Azure did not have load balancers. They had load balancers at the time, but they were what we call regional load balancers, meaning that if you had two servers in the same region here, it was possible that you could have a load balancer here and sort of split the traffic there. So the traffic would come into that data center, and then it would get split across however many servers that you have. The problem for me was that my observation was that, hey, if this entire data center went down, you still had the same problem. Your load balancer and every single thing in there went down with it. And this was a problem that Azure had on the early days. So we were looking for a solution that could load balance across this thing. In fact, this was such a big issue for us that we had used servers in East US, West US, and Central US, Ohio or something like that. And then we would have one server in Canada, because we're Canadian, go Canadians, to deal with traffic. So you would either get East US, West US, or you would get sort of a Canadian server. And that's how we would kind of load balance things. Azure Front Door allowed us to have that flexibility because it was not tied to a specific region. What Azure Front Door had was they would sort of do DNS round robin and all this type of stuff to kind of route traffic to the different regions automatically. And if one failed over, they had the capabilities of failing over to whatever region so that you had a global load balancing system. And that's what we did. And that's the reason why Front Door became critical for us over the time. The next thing that's not so immediate obvious from this diagram was the fact that we were actually creating at the time one database per customer. And that's because, we're running a SaaS application. So we would have our users log in, and then depending on whenever they come into the system, depending on the business logic, they would get routed to the specific database for their data. And that data would either be sitting either in Canada or in the US or wherever, depending on the customer, because data sovereignty, etc. So these were sort of the issues that we had. And that was the reason why we made that decision earlier on, that we could sort of co-locate your data wherever you are, have it closest to you. And theoretically speaking, with Azure's networking, we could sort of route that traffic faster to your region. This came with some interesting challenges in the sense that for every customer that we had Azure DevOps, which is I'm not even having a conversation about the DevOps part because that was just craziness. But in this particular case, I'll just talk about it. So we had Azure DevOps, and Azure DevOps, whenever we get a new customer, would be responsible for spinning up a bunch of stuff related to the customer, including the database and a few other configuration settings, etc., to be able to spin. This over time just became a nightmare. Databases are really expensive, so keep spinning up more and more databases became very expensive. And so Azure came out with a solution later on called Azure Pool. So it's a pooling service basically. And essentially what it is, it allows you to buy one subscription to a pool, and then you can put as many databases inside of that pool, and it will kind of pool the resources. So in other words, shared memory, shared compute. And I think if I remember correctly, at the time, in any pool, you could put up to 9 for a specific price. Now, while this sounds good in theory, we have never really gotten the gains. What we would find is that we would have one customer with very spiky workloads, and they would kind of max out the pool, and then the other databases would suffer. But then, that database that customer, like the load was not big enough that it needed its own database. So because of the spikiness of the workloads, we just couldn't find the right balance between paying for performance and sort of like being able to balance sort of like the small customers with the large customers. So it just became a nightmare to manage. And essentially what it translated to for the customer was they would just have slow performance. In fact, the entire Azure SQL database performance, which is a whole lot of topic and conversation by itself, is that price per performance, I think, is just terrible. This is my subjective opinion here. We've done a lot of testing on this, and based on what we were getting before the cloud and what we were getting with Azure in the cloud, I understand that they have a lot of backup systems and a lot more infrastructure and things like that we're paying for. But just purely on a just pound for pound performance, Azure SQL database in terms of price and performance have never ever delivered, period. We're still in it today. We're still using it for some of our customers, but I'm just being real with you on that. Legit, in my opinion, has not delivered. I'm going to talk about an alternative to that a little bit later on, which I think is one of the most hidden, kept secret in databases, period. So hopefully that's giving you some context into some of the problems that we were dealing with. Now, if you notice, this diagram is kind of getting a little bit more unwieldy, and that's because it literally was. We were adding more and more services over time. So the problem with the one database per customer was it just became a nightmare over time. We ran into efficiency problems, we ran into tuning problems, we constantly had to kind of take databases out the pool. We were constantly trying to play with the workloads. We experimented with scaling up and scaling down. We experimented with Azure Serverless database. None of it worked in the way that we wanted it to, which was really getting decent performance for the price that we were paying. And also, depending on the type of day, depending on the type of hour, some days you'd have good performance, some days you just have bad performance. It was just inconsistent. So as a result of this sort of problem, just constantly rearing its head. We ended up getting to a place where we literally spent a lot of time just dealing with observability. And any architect or developer knows that if you're dealing with the cloud, you just have to monitor things in order to be able to figure things out properly. So then we started introducing things like Redis cache in order to offset data from the database. We started introducing things like Event Hub to sort of ingest traffic data and then slowly sort of like spread it off to downstream systems. CosmoDB was a really good database to start keeping track of historic information. CosmoDB by far, by the way, is one of my favorite databases. It still stands to this day to be my favorite database. And fun fact for you, OpenAI runs on Cosmos DB. It is a highly scalable, extremely efficient, and just an extremely robust database system that has some very, very cool capabilities that is just completely underrated in any startup environment or any of the startup ecosystem. You will hear people talking about DynamoDB, which is the Azure competitor, or on the Google side, you will hear them talking about Firestore. They do not compare to CosmoDB. It is an undisputed silent killer in the database space that nobody knows about and nobody's talking about unless you're in the Azure world and unless you're in deep, complex, global scale NoSQL workloads. That's the only time you know about this database. But it is by far has proven itself, in my opinion, and all of the experience that I have, to just hold up its end. And not only that, extremely cheap. Most people don't know how to use CosmoDB, and so they end up paying out of the wazoo for CosmoDB. But if you understand how to tune your workload specifically for CosmoDB, it is extremely cheap. So going back to this diagram for a second, the web APIs were replaced with Azure functions. And this was sort of like our birthplace into the serverless, like real serverless architecture world. A couple things kind of came about. Number one is we started seeing that, okay, I'm a .NET developer, so I've been focused on .NET for a while. And Microsoft was also going through a complete rewrite of .NET because .NET was traditionally tied to Windows. It wasn't scalable at really, really large scale. The cloud has evolved to a place where they needed to re-architect the entire system. I'm going to argue that they had an opportunity and they missed it, which is to embed AOT, ahead of time compilation, from day one. But that's another story. At the time, they were calling it .NET Core, and they brought out this new thing called Azure Functions. And we jumped on not the first version, the second version, we jumped on the third version because I believe that Microsoft takes a little time to get things right. And I've been burnt by things in the past, entity framework. So I know a thing or two about waiting for Microsoft to kind of get things in track. Functions came along, and Functions was a game changer for a couple of reasons. Number one was it was almost the same thing as having a regular web API. The difference was we didn't have to pay for the server that it was running on until we actually had an execution. In other words, we could deploy the code, and unless a customer hits it, we just didn't have to pay for it. And that was sort of the trigger for me. This was the first glimpse that we could actually start reducing our Azure. Now, at full scale, we were doing about 20K per month in terms of just costs. Now, there's a lot more stuff here that we were paying for because we had some VMs that we were logging into and doing a whole bunch of stuff. So those costs were really expensive. But for the most part, we're hovering around that 20K. And I think, if I remember correctly, once we actually deployed and switched off of the API, our costs for sure dropped at least by like $1,000 or something like that. It was maybe a little more than that, but definitely we got some quick wins from it. Now, it wasn't all what it was hyped up to be because they had some performance issues, scaling issues, but overall we figured out how to scale Azure Functions really well by just replicating it across North America. We had functions in every region, and we were using Azure Front Door to basically just load balance those functions. And that actually proved to be an extremely effective strategy. Azure Functions goes to sleep after 5 minutes. And so we just had uptime system that would just ping it every minute to keep them alive. Because the cost was so cheap, it didn't matter to us. And so we just kept them alive the entire time. And that proved really well. So we never had to deal with the cold start problem, period. It was just a thing. The only time we would have to do a cold start is when we do a deployment. And normally with that, we would just shut off one of the routing, deploy, hit it a couple times, let it wake up, and then we would re-enable the traffic to that region, and we would keep doing that for every one of the functions until we get a rollout. But as you can see, the orchestration just started to become more and more complex. At that time, we also started using Azure Key Vault paired with Azure Function in order to deal with connection strings and all that kind of stuff, secret stuff. And that became a problem because we actually, in the early days, we ran into an issue where, because of the amount of requests that would come in, and poor code, I will admit this, poor writing of code, we would run into socket limitations on Azure functions. There were some limitations on how many socket connections you could open. Our code was basically opening up connections but not necessarily closing them fast enough or at all. And as a result, we started maxing out in terms of connection with Key Vault. That became a huge pain. Took us really a while to solve that problem, rewrite some of our code, etc. We started using app configuration, which is basically Key Vault, but not necessarily a secret version. App configuration had better ways to cache the data locally within the application code and only periodically check for new changes. So we, as a result, didn't have to exhaust our sockets on connecting to Key Vault every single time. Azure Service Bus has always been a rock solid solution. The primary reason that we were using it was basically for our print server. We had a print server that relied on Windows. I talked about this in another video with Azure containers, with my container video for CloudFlare. The print server has a print document that we would use to print PDFs, Microsoft Word documents, etc. It was running on Windows. That was using a Azure VM scale set. Scale set means that it's basically Windows. It's Kubernetes without Kubernetes. You allow Windows to predefine scale up during certain times based on certain workloads and scale down, and had a way to kind of create a template and have that scale up. And that's what we were using to kind of get things going correctly. We had the cache in order to sort of help with the database issues that we were running into performance wise. Azure Logic App was just there to kind of help orchestrate a lot of internal type stuff. And then we had Application Insight and SignalR. We experimented with this quite a bit in order to kind of push real-time updates to our application. That was sort of the reason. So overall, that's been sort of like the general core of just my experience with Azure as a whole. Now, obviously, I'm sort of, this is just a high level, just really just a kind of level set and just give you sort of like a context so you could understand how my evolution as a developer, as an architect, as a business owner has kind of evolved, and the sheer level of complexity that we kept adding on layers upon layers upon layers. And to be honest with you, this is just a very simplified diagram of what we actually had. This is a kind of a closer picture to what it looked like. We had a bunch of API management layers. We had a whole bunch of function layers. Some of it was bringing the traffic in, going to event hubs, sending it to CosmoDB, then a whole bunch of background services. These were all functions. Like I said, just n number of databases for every single customer across the entire system. And there was just a lot of stuff, including change feed, which was taking data off of CosmoDB and triggering it to then do additional work as a workload. And this is just a little bit more granular details. When data come in, as an example, it would sort of get split across whether it's an import data, create or read, update data. This became really complex to manage over time. One of the reasons is that if, let's say, Azure Service Bus or Event Hub had a problem, they didn't process the data, tracing it, we had to have observability tools and stuff like that to kind of monitor things. And the needle in a haystack problem of having to just find where the problem is became a really big problem. We ended up bringing in tools like Datadog to kind of manage login, nightmare, super expensive, backed out to that. We brought in tools like New Relic, also super expensive, didn't work out for us because of costs. So we spent a lot of time building out complex solutions. We were a startup. We weren't making that much money. Our cost was just exuberant, and we were playing catch up, trying to get to a place where we can flip the switch. So this balancing act of trying to deal with the dependencies, deal with the costs, deal with the latency, deal with the outages of Azure, deal with the scaling problems, trying to deal with just the complexity of getting the deployment, trying to deal with the lack of documentation, because every single time we would fix the problem, we would move on to another solution, probably don't have it documented properly. Trying to deal with me having to manage a lot of the stuff because I was sort of the senior CTO and entrepreneur and managing, I think, We had like 6 or 7 developers at a time. It was just a lot. And so just juggling this whirl of complexity, trying to keep this application alive while we sell, while we try to convince other customers to come on board, while we deal with customer service, while we deal with, like, it's just a lot to deal with overall. And that complexity never went away. If you're going to build an enterprise level system, the complexity across the board, it's a lot to deal with. And especially if you don't have the resources to hire people across the board to deal with it. This need to reduce this complexity, this need to simplify, drive costs down in order for us to get a sustainable business is what really started forcing my hand. Now, I want to talk just a little bit. I'm jumping around in my timelines here, but still trying to give you a picture so that you can understand why I'm so bullish about the future of where Cloudflare is going and what's going on over there. There's 2 things that, from a technology standpoint, that really pushed me. Number one was Microsoft is a fantastic company. They've been around for a while. They got lots of things going for them. It's the only company in my knowledge in history that's been able to transform themselves from like a dinosaur to just like a V8 engine just kicking on all cylinders. Like, they have, as a company, as a cloud solution provider, they were way behind on AWS, way behind on AWS. And that is not the case today. And they're arguably the leader in this AI revolution with partnership with OpenAI. That's a different conversation, but they have changed the game. So this is not a knock on Microsoft or what they're doing, but I have some very specific thoughts that I want to kind of cover. Number one, because I was a .NET fan, I've always been a .NET fan. I grew up in Microsoft .NET. I went to school. I learned .NET. I was like, this is great technology. It's good. Before that, I did Perl, Python, and PHP, and all this type of stuff. None of it stuck. But .NET, I was productive in .NET, and I'm still the most productive writing code in C#. I drank the Kool-Aid of Microsoft. I want to be clear with this. I drank the Kool-Aid. In fact, I swam in the Kool-Aid of Microsoft. And over time, what happened was Microsoft it started happening around 2012, 2013, 2014, 2015. Microsoft started in the developer space. They were losing grounds. They weren't the cool kid on the block. The technology was changing. React was already out. Angular was out. React came out. Vue, Knockout.js. There was quite a few other technologies back then. And Microsoft just did not get the memo. So they kept bringing out and doing the same framework stuff over and over. For me personally, what was happening at their time was customers were pushing us. What iPhone was out, iPad was out. People were getting accustomed to just swiping, clicking, and the expectation was just completely different. And as a result of that, we were forced to move. One of the first jump that I did as a programmer, as a developer, was I swapped over and I started doing Angular development. We went to Angular. We did Angular 1.1, we did Angular 1.5, and we built out an entire mapping system. I was getting quite a bit of money from this company to build out a mapping system for them to be able to plot maps or whatever using Google Maps as frame. And then we tried to run it on an iPad, and that was a nightmare because we couldn't get this thing to run on the iPad properly. We just couldn't. Angular 1.5 had a very specific problem. You would see, if you open up the dev tools, you would just see components after components after components after components, and they had this thing called a digest that would just eat up and just chew up resources. Long story short is, it was a nightmare. It didn't work, and then they had to switch and they went to Angular 2.0 or something like that. And it was a complete rewrite. And that was when I just threw up the towel, because we'd already spent like a year and a half, nearly 2 years doing Angular, and it was just a nightmare. And then React and some of the other platforms came about, and I looked at React, and at the time I was like, I am not touching that. Like, first of all, I don't like JavaScript. Intermingling JavaScript and HTML just seems like a stupid idea to me. That was my opinion then. Probably still is my opinion now, even though I know React has won the game. So with this context, and again, I'm giving you this context so you can understand my sort of like my bullishness on certain things today. So with this sort of thought process in mind, we needed to find something better. My observation was that Microsoft was not it, because they were not moving fast enough and they were not keeping up with all the cool tools in the JavaScript community. And so slowly after time and after coming to the realization that Microsoft was never going to update their platform fast enough, we just have to jump shift. Now pair that with the complexity that I just showed you around the entire application, all of this stuff here, the cost was getting too much for us. It was just too much to maintain all these web applications because the customer expected the speed, but in order for us to get the speed, we had to keep cranking the dial on the server side and paying these exuberant costs. So I came up with one simple thought process at the time, which I thought was revolutionary. It was just standard. Today's just standard, but back then it was. I was like, we have to get the compute processing off of the servers and onto the user's computer. The compute has to get to the front of the line. So let me just explain. Mainly for the non-technical people. So let's say you have a lab and you got a user that's browsing the internet. Okay. There's a server somewhere at the back here that's doing your processing of that data. So traditionally, when you visit a website, that website will just basically compose the HTML and it just sends you the end result. So the more requests that you get on this server, the bigger this server has to be in order to process these requests. And that just translates to dollars, more money. So because of the cost that we were incurring, it was very clear to me that we needed to just get rid of this cost. And the computers and the iPads and the mobile phones were just getting powerful enough. So my thought process at the time, again, revolutionary, today it's just standard, was we need to move that cost to the front end. And the only way to do that was JavaScript. And you're talking to somebody that was a .NET developer that came from a very structured programming language like Java and this type of stuff. And JavaScript was like the curse of the earth. It was literally, it was like you are committing the ultimate sin if you write JavaScript code. But I made this choice because I recognized number one was that .NET was going to drown me. It was just going to swallow me whole. And number two was that the cheapest way for me to run my application was to do JavaScript. That's number one. That was the first thing that made me realize I need to move. The second thing was just the cost. If I could get the compute to happen on the user side, then that significantly changes the cost structure. And the third was just the fact that JavaScript just brought interactivity. Okay. Now we won't talk about all the problems that JavaScript has overall, but it's just the interactivity as a whole. It was like, this is the clear winner. So when I ran the numbers, it was very clear that if I moved my cost there and I only paid for Azure functions, just for only serverless, that we pay only for requests, that we would be able to significantly reduce our cost. And we tried serverless database, but that was just a failure. In fact, we got some stupid bills from Azure because we tried some things there. So this was the insight that I had at the time. And this is what made me started going down this rabbit hole of learning JavaScript, first of all. Because I was like, I need to not be a .NET developer and I need to be a JavaScript developer first. And so I started shifting and learning this language. I gave myself a Christmas holiday weekend to just embed myself in JavaScript and just learn it inside out. And it took me the next year, maybe 2 years to move from, okay, I get it, to JavaScript is a really powerful language. That took a while. But once I saw the power, then it was for me to find a framework that wouldn't make me go crazy. And this is where Vue.js came in, Vue.js. And I have to say, Evan U is a godsend. I'm sorry, but it's how I feel about it. Evan U. So this guy, the creator of Vue.js, is also the creator of Vite, which is now taking over the world, and a few other stuff that is just now getting caught up. In my opinion, the JavaScript community is now getting caught up to how good of a developer Evan U is. But back then, I recognized that the Vue.js sort of framework, the ecosystem, the way that this guy was thinking about front end was just fundamentally different, and it aligned with my principles, which were, it felt like the person that wrote Angular was like a technical person. The terminology, every single thing they were using was just highly technical. And I'm more of a visual person, and Evan U and the way that he wrote Vue.js is just super elegant. The procedures, the thought process, at the time it was being considered as a progressive framework, which means that if you knew jQuery, you could then swap that out for Vue.js and continue working. And it just was an elegant solution. And then Nuxt.js, Nuxt came about. And that even added a more simpler UI layer and addressed some of the problems. And we just jumped 100% all in on that framework. In fact, this book here proves it. Like, this was my first book into the Nuxt.js ecosystem, the Vue.js framework. And it was just phenomenal because for the first time, I actually felt like JavaScript just like was a really elegant language that could do some really, really cool stuff. And we just went all in on that. But like I said, it wasn't because we just wanted to write JavaScript. It was because I was solving a real pain point problem of cutting costs as a business owner. And any business owner knows out there, you got to cut your costs. And this was one of them, those shifts that we made. Fast forward later on, Microsoft recognized that they needed to play catch up and they brought out Blazor. And since then, they've been trying to play catch up with. I think it's a little too late. They're trying. It's a good framework. It has some really good, cool things. I since went back and built a few things because I'm a diehard C# fan. So I wanted to check it out for myself. So I built a few applications inside of it for production, for startups. Knowing what I know about Vue.js ecosystem, Nuxt.js ecosystem, and some of the stuff that you have in the JavaScript community, Blazor is just way behind and they're still playing catch up. And I don't think they ever will get caught up until, I'm going to put an asterisk there and say, until WebAssembly comes along. And when WebAssembly comes along, it's going to be a whole lot of game, but that's yet to be seen. So I put an asterisk there and I reserve the right to go back to Blazor whenever they get it right for WebAssembly. All right, so now that you kind of have a good understanding of my motivation, how things just sort of evolve, the level of complexity, the need to simplify the complexity, the growing pains, etc. We're going to talk a little bit more about how I started transitioning away from Azure. And again, this is not a zero sum. It's not all or nothing. We're still on CloudFlare. We're still on Azure. And we're always going to be in Azure for some things. That's just a reality. We're going to talk a little bit more in this video about when you should use Azure, when you should use CloudFlare. But I just want to make sure that at least we've level set so you understand exactly how I've evolved, what were the growing pains that kind of forced me to find better solutions. So with that, let's just talk about the first jump. So like I said, now that we've kind of moved over to CloudFlare and CloudFlare now that I've kind of realized that JavaScript was sort of the primary mission to be able to offload a lot of the workload onto the client, and Vue.js became sort of my preferred choice of platform. The first move that we did was we took that front end and we basically just tried to isolate it, and we just took it and we just dropped it over on CloudFlare, okay, CF. And that was the first thing that we did. And at the time, that was a fantastic move. It still is a fantastic move. And what was crazy about it, it was free. It was 100% free. And I gotta stress this. The web application, I don't remember the exact number, but I think we were paying somewhere around anywhere between $1,500 to $2,000 per month because of the fact that it was load balance or whatever. One server was probably around $400 to $700 per month or something like that. And we moved all of those workloads and we dropped it over after rewriting most parts of Frontend for CloudFlare. Now, the truth is, actually, let me take a step back. It wasn't 100% like we just rewrote the entire application because it was a pretty big application. What we did was we started building the outer parts of the application in JavaScript, and then we started iframing certain parts to the old application, and that was kind of how we started doing the transition. We just kept doing iframe and JavaScript parts, and then we would just transition a page from the iframe from the old application to the new application, and we kept doing that process until we phased out all of the old application. In fact, we actually went through like 2 or 3 iterations of that exact same process to get it right. But the point is, as we did that transition from .NET to JavaScript, we kept moving those parts over to CloudFlare, and our costs just kept going down. And that was a huge eye-opener for me because at the time, and this is still the case today, the way CloudFlare charges you for their hosting is by builds. I'll explain what I mean by that. So whenever you check in code as a developer, you normally check it into GitHub in this particular case, GH, and GitHub normally pushes it over to CloudFlare. CloudFlare has to then compile that code. We're going to use that word in this particular case. It's JavaScript, so it's never true compile, but for the non-technical people, they normally package the code is probably a word to use. And when they package the code, CloudFlare charges you for the time it takes to process, to package that code. Well, guess what? Our application was so small content-wise that there was literally no cost because Cloudflare had an extremely generous tier in build time. So there was literally no build time. And so we just never had to pay. In fact, to this day, we've never seen a bill from Cloudflare for this particular application in particular. And you have to understand that we're coming from $2,000 per month of just front-end charges. So getting that all the way down to zero, you better believe that I became a convert. And on top of that, the performance of the application dramatically increased. The load time was significantly better. The speed, the time to actually getting the user's sort of like result just dramatically increased. And so that became the selling point for us. And from then I had all of my developers pushing towards moving over to JavaScript, which in turn meant Cloudflare. And we were going from JavaScript to backend to API manager to Azure functions. And as I mentioned before, we've dramatically decreased our costs with Azure functions, which still to this day is still a really good solution and option. So that was the motivation, that was the driving factor, and that became the architecture infrastructure. And then we slowly started migrating and cutting different services as we moved forward. So more importantly, the thing that made me really started becoming a convert of Cloudflare altogether is that we never had to think about load balancing. And as I mentioned to you, this complexity that kept growing and growing of having to deal with load switching and all that kind of stuff. This concept of just deploying to region Earth just really got solidified in my head that if I do a deployment, I don't have to think about the load balancing part. I just deploy, and Cloudflare deals with the scaling, and it just worked. And the latency was just phenomenal. Like the latency, the speed, the performance overall of the application was just fantastic. Okay, so hopefully you've kind of gotten a good understanding of not only sort of like my background, but also sort of like my motivation, my drivers, and why I've been sort of like shifting gears into Cloudflare, how I'm thinking about sort of like the overall architecture between the different platforms, etc. The reason why I felt like that was important is because sometimes like you don't understand what are people's motivation, right? Like I'm not being first of all, I'm not being paid by Cloudflare at the time of this recording. I want to be clear with that. So maybe in the future, I do have plans of maybe hitting up Cloudflare guys and saying, hey man, can you pay me for some of this content that I'm putting out for you guys? Like I'm a business person. I'm all about money. So if I can make money on this stuff, I'm happy to do that. But right now I'm sharing my experience purely because it took me a really long time to figure this out. I see that Cloudflare is clearly the future. I know that Cloudflare is going to get significantly bigger. That is very obvious to me right now. And I understand very clearly, recording this video right now, that while the startup ecosystem is not 100% on board right now, everybody's on Vercel and Netflix and all this kind of stuff, eventually Cloudflare will win this. I'm calling it as it is right now because it's very, very clear from what they're doing, unless the other cloud providers, AWS and Google and Apple, come out with competent solutions and develop sort of like the speed and the ecosystem around their platform to just deploy at the scale at which they're doing. So with that being said, let's just take a step back and let's just think about an application as a whole. And when I say application, I'm talking about specifically business type applications, SaaS type applications altogether. And what I want to do is really just peel back the curtain and simplify an application in abstract so that you could understand how I think about the different technologies and how to approach when you should use Cloudflare versus when you should use Azure. Before I go too deep into that, I want to talk about my philosophy. There's a lot of technology out there that you could be using. Anywhere from Heroku to Netlify, like you name it, there's tons of platforms out there. There's tons of applications out there is my point. Here's my philosophy. I will not put my data, like enterprise level data, on a startup database infrastructure. This might sound a little old school, maybe even a little bit biased, but when it comes to data, like if you're now one of the big three, I'm not even touching you. I will go to Oracle before I put my data on a startup sort of database system. And that's not a knock on startup because I'm a startup. It's just that one of the things that has kind of skewed my vision of startups is this. With the nature of capitalism, and this is not a conversation about capitalism versus whatever, I'm just telling you sort of my outlook. I've had tons of applications that I've used in the past where I'm all in on it, only to find that the startup was sold to a VC, a private equity firm, or something of the sort, or they got acquired, and all of a sudden innovation dies. You're not seeing as much updates anymore, and slowly the platform just kind of slowly degrades. This has happened to me time and time again. So when it comes to my data, I will pay more because it's sitting in one of the big 3 or 4, if you want to put Oracle and maybe IBM or whoever else in that pitch, but it's sitting in one of the big cloud providers, and I know that they're not going anywhere. Like, they're just getting bigger and bigger and bigger, and sure, in some cases they're more expensive, but at least I know that they're not getting acquired. So this is kind of like my core philosophy. This is a fundamental belief. It's like a bedrock. You cannot change this perception of value that I have when it comes to the big 3 altogether. So I will never move my data outside of those core platforms. That being said, I will move adjacent data outside of those platforms because I have no problems doing that. Because if in the event that, let's pretend for a second, one of those startups died, I will still have my data in a big platform and I could do without that data, whatever it is. So in other words, I will have sort of supplementary data on those smaller platforms, but the core of my data will always sit in the big 3. This is just a fundamental principle that I live by as a developer. In the enterprise level world, like, banks are not putting their data on startup technology, right? They're sitting in the big 3. That's just how it is. So that's kind of the core philosophy there. When it comes to like JavaScript and all of the front end stuff, the layer stuff, I am more than happy to put my applications any and everywhere in any cloud provider whatsoever, because it all points back to the core data. And so if one of those things go down or thing, I can always swap them very easily. The cost of swapping my front end is very light. So with that in mind, let's just think about just a little bit at a high level and simplify any business level type application. So any single thing in the SaaS space, any sort of enterprise application, any application that works in Chrome for the most part in a browser will follow this principle regardless of the type of application. At the end of the day, most applications are essentially just glorified Excel spreadsheets, right? They're an Excel spreadsheet, aka a database, sitting in the back end with a fancy interface. It doesn't matter whether it's Salesforce, Microsoft Dynamics, or it's HubSpot for marketing, right? Or whatever tool you put in front of it. It's a glorified database, Excel spreadsheet. That's how I think of it. So if you were to think of that as true, then you would have essentially boiled it down to these 5 layers altogether. So the first layer is, for any application, you need some sort of security layer. That security layer has to do with either login, authentication, WAP, which I recognize, WAF, which I recognize I mentioned earlier, but didn't actually mention what the acronym was, which is Web Application Firewall. Okay, so all that on the security layer, any application that's any sort of large mainstream application will have something like that. A security layer for authentication and some sort of firewall protection. Okay, so that's standard. Next up, you're going to have a UI layer. An UI layer, generally speaking, it doesn't matter which language. We're talking JS in this particular case, but that layer could be Blazor even. Our layer could be PHP. It doesn't really matter. On the end of the day, it's a UI layer that is basically responsible for showing data on the screen. And that will obviously translate to some sort of business logic layer. And again, doesn't matter. This could be in Go, right? This could be in Node, right? This could be in this could be in PHP. It doesn't matter what the layer is. The point is that there's some sort of business logic that is responsible for a bunch of if and else statements that is responsible for routing data according to the user's input. And then most times, in most case system, there's some sort of scheduling. Scheduling will be something like a queue system, or it might be some sort of timer system, right? Or something where there's some sort of background job that's happening, right? If it's a calendar, it's putting it in the future. If it's sort of like processing data, you can push it in the future, or right, like there's some sort of background system that has to do something when the user is not clicking buttons on the screen, right? If you're sending transactions, for example, if you're sending money, maybe you could send $20 to your friend and it needs to arrive in their account next week, but you're doing it today, like that kind of stuff, right? And last but not least, at the end of the day, whatever happens at the top, the data has to sit somewhere and be stored somewhere. So in most cases, that is a database. And if it's not a database, it's probably just some blob storage, some sort of file storage on some server somewhere for the most part, right? Obviously, I'm simplifying, I'm abstracting a lot of details here, but the point is that I want to make sure that we're kind of thinking about an application in this sort of very basic, primitive sort of format. Now, if you agree with this sort of diagram structure in terms of an application altogether, then this is how I am today thinking about CloudFlare versus Azure. I want to just make sure that we understand at a high level how I'm thinking about it. So right now, my subjective opinion here on the balance of cost and speed, performance, latency, and time to value, CloudFlare is winning on the side. They have some business logic. We'll talk about it. First of all, on the security front, CloudFlare by default was a security company at first. Okay. So that's not to say that Microsoft is not secure. We're not having that conversation here. All we're saying is that CloudFlare won the security game because that's what they started with. Microsoft has been every single thing to anything right across the board. They're a security company, they're a Windows company, they're an operating system, but they're not just hyper focused on one thing. Whereas CloudFlare was hyper focused on security from day one. That's their thing. So that's what they excel at. And most people, when they come to like protecting their application on the internet, they go to CloudFlare. Okay. It's just how it is. 20%, these guys didn't get to 20% or 20 or 25% of the world's internet traffic going through their network just by like accident. There's a reason why the whole is front end is because of the security. So CloudFlare, I will say, win this game for sure. All right. Secondly, when it comes to the layer, I will say CloudFlare has also won this game. Why? Because of their CDN, their content delivery network. Okay. They're quoting something like 350 locations or 350 cities where they have their servers located. It's more than Azure and it's more than AWS. So they just have more servers distributed so they can have low latency. And if you're doing any single thing on JavaScript in the JavaScript world, dropping your data on CloudFlare, so your web application on CloudFlare just makes sense because it's just everywhere across the entire globe and you don't have to think of load balancing. Now, let's talk about the different offerings in a bit. I just want to kind of highlight the pieces first and then I'll go into the different offerings between the different providers. Now, when it comes to business logic, this is where it gets a little hairy. Okay, so you'll have to kind of bear with me on this one. CloudFlare does not win the game 100% here. Okay, it's kind of a half and half. CloudFlare has some solutions that will help you with business logic, but I don't think it's the final and be all. In fact, there's a lot of things that is missing. We'll talk about that in a bit. Okay, their worker solution is bar none the best when it comes to like taking in traffic, doing some processing and pushing it back to the user. It is efficient and it's very fast. And this is where you can put business logic in there. I'm going to argue that there's some nuances there that will prevent you from not putting all of your business logic there. But for the most part, they've taken that initial sort of front end heavy sort of request coming in and doing some initial processing on it. CloudFlare wins that game all day long, for sure. Okay. Now, the way how I've been thinking about it is that, you know, these workers should be really light workers that come in and either do one of two things. They should be going to cache to pull data from CloudFlare cache and sending it back out to the user really fast, or they should be going to cache, not hitting cache and then passing it on to backend systems that will pull the data. And CloudFlare can play that game all day long because it's just an extremely efficient sort of system in order to do that properly. Where CloudFlare starts to break down a little bit, at least for me, and again, oversimplifying and thinking, is number one, is they just recently brought out containers to kind of solve some of these problems. But the CloudFlare worker doesn't have a proper way to talk from a worker directly to a database. It doesn't have a good integration for that. You have to use what they call a hyperdrive system or something like that, that allows you to kind of connect to a database and sort of wonky. What it basically means is that let's pretend that this is the globe and you have all the workers all over the place. If you have one database system and you have all these workers because you have all this traffic coming from different workers, it's possible that you would flood your database with too many connections and you're going to overpower your database because of things. So you can't do this. What you have to do is you have to have some kind of like a centralized system. So all these workers kind of forward their requests into it first, and then that worker kind of be responsible for pooling the connection and pushing it to your database. And for this reason, it's not the best solution, in my opinion, at this particular point. In order to think, it's kind of like a kludge of a system in order to get you some gains to talk to your database. So I would never do this approach. Okay. The way how I think about it is that front end should be doing like very light, very efficient, very streamlined sort of processing, and then push it to backend systems that could then do the heavy lifting, that could then talk to a database. And then that means you're in AWS world, or you're in Azure world, or you're in Google world altogether. The other thing that Cloudflare is still getting on board is so their queue system seems to be pretty robust for sure, but Azure definitely still wins this game when it comes to like really large, complex scheduling system. Now, that being said, queues in Cloudflare, I would say, is as good as Service Bus, with some caveat. And also Service Bus has, I would say, more robust enterprise level options that is not necessarily readily available with queues. That being said, on the surface, they both do the same thing. They both do a fantastic job, but Azure just had a little bit more sort of experience in this world, and they've addressed a few more edge cases that is not necessarily in the Cloudflare world. And then on the database side, it's not even a question. Azure win this game. Okay. Now Cloudflare does have a D1 database. It's a NoSQL database. It has a maximum of like 10 GB. And the way how they think about it is that with 10 GB is pretty good for decent sized application, but what they want you to do is have multiple databases, etc. Just doesn't work for me. Even if it's Azure SQL database, I've talked about some of the problems there already. It's still way better for large volume. And then my new favorite in Azure, I wouldn't say favorite, but it's definitely a proper database hidden away in Azure is, get this, it's Azure Cosmos DB for Postgres. Go figure. Azure Cosmos DB for database. It's a database that's hidden underneath Cosmos DB. Cosmos DB is also my go-to database for NoSQL. Cosmos DB is a competitor to MongoDB. In fact, it actually has, if you have MongoDB, you could literally point it to Azure Cosmos DB and it will work 100% out of the box with not a single change on your front end. It's 100% compatible with MongoDB. So when it comes to the storage layer, I just don't mess around with any single thing else. It's not even a question for me. I might put my stuff in Google, I might put stuff in AWS, but right now all my stuff is sitting in Azure. It's not going any single way. There is one caveat to that, which is the exception with Cloudflare R2, which is basically their storage service, which you could do a streaming service on top of it. That's a little different story because Cloudflare actually has a pretty good story for streaming videos and that kind of deal. So hopefully I've kind of given you some kind of a breakdown of how to think about at least the different layers in the abstract, right? Obviously this is still high level. I just want to use this as a leveling playing field so at least you could understand the different layers. What we're going to try to do in the next section, go a little bit deeper and talk resource for resource and just pricing so that you can get a better understanding of why Cloudflare versus Azure from a pricing standpoint, just how the pricing works. So if we were to keep that layer in our mind just as a high level, what I want to do is just kind of compare some from a pricing standpoint. Now this is not a one-to-one apples to apples comparison. It's just to give you sort of a framework to kind of think about things. Again, just kind of keeping that abstract. Obviously, you're going to have to do your own research. Obviously, you're going to have to sort of like do your own comparison based on your workloads and all that kind of stuff. And this is literally just a ChatGPT sort of a head-to-head comparison, just so at least you could get some understanding. Not to go into the granular details specifically on pricing, right? Because it varies depending on the volume, ingestion, traffic fees, etc. Okay. That being said, though, let's just talk about this all together. So with the security layer, we're not talking about Azure B2C. It was Azure Front Door is what we were doing. Azure Front Door. One of the things that I noticed right off the top, there was a base fee. Okay. And that base fee was kind of a range depending on the type of thing. There was a cost attached to it. So just to bring up some actual numbers, just so at least we could talk about very quickly. I won't do this for everything, but I just want to kind of just talk about just at a high level. So as I mentioned, we were using Azure Front Door for a while. And with Azure Front Door, it's a great service. It's fantastic. You have some pretty good things, but again, on the base level, it's $35 right off the top. That's just for one service altogether. And still, with that, there's still some traffic costs that you have to pay for that sometimes end up creeping up your costs a little bit that you don't necessarily think about. Okay. Now, again, this is not a head-to-head comparison. I just want to make sure that you understand some of the nuances and the pricing with Azure. So one of the things that always got us is that we would see, okay, $35 a month. Great. We could do that. But then next thing you know, our bill is actually 75 or $80 a month because of the fact that we have traffic coming through and it's costing us more. So that was sort of the thing that I just didn't like about Azure. It's like I get quoted one thing, but then my cost is different. And then it depends on which region you're in also. That was sort of a thing that was just really annoying about Azure altogether. So I could never really truly get a handle on my costs. It just kept creeping. Now, compare that to CloudFlare, okay? And again, I'm not saying this is 100% apples to apples. They have a $20 per month, they have a $200 per month plan, and they do very different things. I want to acknowledge that altogether. But at a $20 per month, you could get a web application firewall, which is basically doing what Azure Front Door is doing, because I think with Azure Front Door you have to pay extra for the web application firewall. Don't quote me on that, but I think that's how it used to be. I think they might have changed that recently. So anyway, you get a web application firewall, and now I could do that. So here, let's see, you get bot mitigation, which comes with Azure Firewall altogether. Sorry, Azure Front Door. And then if I add an extra $5 a month, I could get the load balancing. So the same load balancing that I would get with Front Door for that $20 and that $25 a month, I could accomplish roughly the same thing. Again, the details matter here, depends on your workload, depends on all that kind of stuff. But my point is that the pricing model is just significantly simpler. It's actually $25 per month if you do it on a monthly basis, right? So call it $30. Whereas for this here at $35, I'm just on one service. So that was the thing that got me very, very interested, at least from a pricing standpoint. I was like, wow, these guys understand it, especially if you're a small business and you're just trying to survive. So that was one that was really fascinating to me. The other thing, now compare that to AWS Cognito, which I really won't talk too much, right? They're suggesting that it's about $55 per month, right? So 35 in Azure ranging, right? $55 per month. This zero trust is not accurate because this is not what we're talking about right here. Again, this is a ChatGPT sort of like thing. It's really the WAF, the sort of security, and it's not per seat, okay? It's just sort of a flat fee altogether. So just kind of keep that in mind when you pay the $20 per month for Azure. Now, on the function side, flex consumption is $20 per month, $20 per month for a 1 million execution. I can't say much about flex consumption in the sense that we've never really seen a really, really large bill from Azure Functions altogether. It's actually a phenomenal service altogether. It works really good. That being said, it's never close. It's not even nearly as close as cheap to work. It definitely is more powerful, but it's not nearly as close. But for me, flex consumption wins all day long. It's a really good service. By the way, what flex consumption is the next version, it's a newest version of Azure Functions. The older version was not as good for scaling. Flex consumptions, the older version would only scale up to 200 load balance. If a request is coming in, it could only spin up to 200 requests at a function at a time, whereas flex consumption will go up to 1,000 functions automatically at a time. So flex consumption is just significantly better. It only runs on Linux hardware. It does not run on Windows, which was a limitation before. Workers, on the other hand, clearly wins in this particular case is the fact that it runs across the entire globe. So I don't know what other load balancer you need when you're literally running at global scale all the time, every time, for $5 per month. It's just stupid pricing, right? So you just can't beat that. Now, I will admit the power difference is significant. As I mentioned before, with a worker, you can't connect directly to an SQL database. So you still have to do that. So essentially what we do is, we do a lot of front-end processing on workers, and then we just route back to a function to do back-end database type stuff, right? Going through API management and that kind of stuff for some security layer, right? So that's super, super important. But the point is that, we use both of these services. Lambda, I can't really say too much about it because I'm not really a big Lambda person. I find that the implementation of .NET is just not the best. And so for that reason, I just don't really do much with Lambda in that regards. But just, giving you some comparison here, it's once you start understanding where the value is with CloudFlare, you could clearly see the wins from a money perspective. We use a lot of service bus. We're scaling out. We're removing our service bus and we're going in favor of queue. Again, because of that $5 per month. The default main service for Service Bus the base model costs $10 per month. Okay. Just a standard base model, just to have the service. Whereas it's $5 per month here. And the amount of requests that you can do on queues and workers with cron jobs is just significantly higher. Plus, because of the lack of cold start problem, it's actually much, much faster. We have some issues with pairing Service Bus and functions together. I won't go into too much details there, but they basically, if the function goes to sleep, at least in the old system, I can't really speak too much on flex consumption because they've done some magic to kind of not make that happen. But in the older implementation, if the function went to sleep, the Service Bus wouldn't trigger the function, and there were some issues there altogether. In terms of Azure, AWS, they have their step functions, which is the equivalent of Logic App. Again, can't really talk too much there because I haven't really do that. Now, Cosmo DB, like I said, I'm a diehard fan of this application. It is just really, really rock solid. AWS will argue that their system is better. That's totally fine. We don't use RDS on AWS. We don't use DynamoDB. Cosmo DB is just like, it's just what it does and how it's implemented. It's just really, really elegant. Yeah. Anyway, like I said, this is not an exhaustive comparison of pricing. Is just to give you some understanding of like where the clear wins are with Cloudflare. And if you look here, like just based on what they're showing at this particular point, they're suggesting that $200 per month for Azure, $175 on AWS. AWS is definitely cheaper than Azure, like across the board, like at a sort of a macro level. Cloudflare, $28 per month. Right? Obviously, it's not an apples to apples 100% comparison, but it's just to give you some idea of like the value that you're getting for the price point. Right? 86% less cost is nothing to sneeze about. It's just a phenomenal value altogether. So with that, I just think it's one of the kept hidden secrets. Actually, speaking about hidden secrets, let's talk about the database. The Azure Cosmo DB for Postgres is by far the cheapest database that has the scale that you need hidden in Azure that nobody is talking about and nobody even knows. I don't even think the people in Azure that have been diehard Azure fan knows about this database. And so we've been slowly migrating our workloads to Postgres database that's sitting underneath Cosmo DB for whatever reason, and they've given it the name Azure Cosmo DB for Postgres. It's just bizarre because they already have a product called Azure for Postgres, which we do not use. As a very different service with very different pricing. Overall, what we've been able to do is remove ourselves from the level of complexity as I've been showing you before from all the different services, and what we've essentially done is brought it down to this. Now we're still using a bunch of Azure services, but more and more we've just been switching a lot of stuff over to cloud. So all of our front end, all that type of stuff is in Cloudflare. All of the workers for initial sort of request load is in Cloudflare. All of the routing is slowly moving over to Cloudflare. Some things are in backend. And then when we need to access database, we still pass every single thing through API management. API management still connects to our authentication service, which in this particular case, we connect to our authentication services, which is not Azure B2C. It's Auth0 we use for that. And APIs will connect to the function, push data to Cosmo DB. Right now we're using one single multi-tenant database. So instead of having a database per customer, we've now reverted to one database that just has all customer information and doing a lot of multi-tenancy inside of there. And then we have a sort of background job that's slowly migrating data over to Azure Cosmo DB for PostgreSQL, not Azure Postgres. It's just the most bizarre naming ever. But yeah, this database here, like I've tested it in terms of price per performance, bar none, the best. I will swear by that. Okay. It is hidden, but I've tested this thing. I don't remember the exact numbers. I'm gonna have to look it up and maybe I'll do a video on this. When we tested this database here, don't quote me on these exact numbers, but a rough ballpark. We were paying about $350 per month for this database. And I think at the time we were using the old Azure functions, so they weren't as efficient. But at the time when we were doing some testing, I want to say we were getting something like 100 to maybe 150 requests per second with .NET. Okay. This is like hitting the database before we start maxing out between the .NET application and this database. It was just the connection pool. There was a couple issues there. It was just, now when we tried that directly over with Postgres, and again, don't quote me exactly on the numbers, but it's within the ballpark. By default, we were paying on the smallest database, because I tested it on the smallest database first. The smallest database was like $56. Okay. And just out of the box with, it was a slightly different application, but we were getting somewhere around like 450 to 500 or something like that requests per second. It was something in the average of that. Okay. Proved to me that there was value here because we were getting more requests per second and faster. That being said though, Postgres, we found out very soon after that Postgres has some things with connection pool and blah, blah, whatever the case is. So then we installed, because of how this database works, we installed, I think they call PG Bouncer. For any of my Postgres people out there, you'll know what this is, PG Bouncer. And this is sort of a way to manage connection pool. And when we did that, I kid you not, this connection system managed to jump from 450 all the way to north of like 4,000 requests per second. It was insane. I was so shocked when I saw that difference of just installing this extra tool, and it didn't cost anything because it's the thing. This Azure Cosmos DB for Postgres SQL database is 100% compatible with Postgres. It's using Postgres Citrus, Citrus, under the covers, which is a whole company by itself that somehow has their database under Azure. It allows you to horizontally scale very easily. It's by default, it's designed for that. I don't think anybody that uses Azure knows about this database except for me. Obviously, I'm joking, but my point is that it is that hidden because since they announced it, I haven't seen any new updates about it. In fact, I'm so scared to use it that I'm scared that they're going to discontinue it. But it's so good that I'm willing to take the risk of using it and just hope that it just stays. Yeah, that's my thing. So we're on a path to migrate every single thing in a complete rewrite over to that database because of the speed, the performance, and just the thing. So between Cosmos DB and Postgres, that's what we're going to be using going forward. Hey, hopefully you're getting some value from this entire video. As you can see, this is a long video, lots of complexity, lots of details. I'm skimming over a lot of stuff, but I'm really just hoping that at a very high level, you're able to understand, one, my motivation, two, why I'm so bullish on Cloudflare, and three, where I see the ecosystem going. And hopefully you've gotten some direction that could shape your decision-making process. Whether you decide to go down the Azure route or Cloudflare route, doesn't matter to me. Again, my job is really just to give you the information, bring you to the water, and let you drink from whichever bucket or whichever lake you want to drink from. So with that, by the way, if you're getting value from this video and you haven't subscribed already, I don't know what you're waiting on. Please subscribe. Clearly you're getting value from it. So yeah, and share it with a friend. That would help with the channel quite a bit. If I could make one person win from the content that I'm putting out, that's a win for me. So let's talk a little bit about like just the trajectory of Cloudflare, because this is something that, you know, it's not necessarily obvious to most people, and it wasn't necessarily obvious to me either, because the truth is I wasn't paying attention to Cloudflare for their application and all of the sort of developer stuff. I was like, I just need a fast way to host some stuff, and Cloudflare seems to be the cheapest, so we're just going to do that. And that strategy that I talked about in my previous video about them sort of like giving away things for developers for cheap really worked. That gives you an overview about why Cloudflare is the future. What I want to talk about here is just highlight very quickly just the sort of series of events leading up to where we are with Cloudflare. I'm not going into exhaustive details here. Just want to kind of highlight some things. So R2 is their object storage. This was only 2021. Okay. This is after the pandemic. Okay. That they announced this entire storage, and it's only in 2022 that it went GA. So this is their storage layer, you know, their object block. So you have to understand that this stuff is brand new. And as a result, by this time, 2022, 2021, right? Azure is mature. AWS, mature. Even Google, who was really behind in the race, mature. So with Cloudflare just coming online and saying, hey, we can do storage too, nobody's taking them seriously because everybody's data is sitting in either AWS or Google or Microsoft. That was sort of, at least this is how I'm perceiving things. It's only the new startups that are looking for ways of doing things differently or starting to jump in the ecosystem and realizing the value, and they're building some amazing stuff. But the rest of the world just haven't caught up as yet. Okay, Fast forward a little bit more. They brought in queues 2022 private beta. All right. Queues weren't, let me see, when did queues go GA? It doesn't even have it here. Queues didn't, it doesn't even have it here. So 2022 queues. I know that queues is, obviously GA, I think by now. Fast forward 2023 AI workloads. So this is a big one. So workers AI. And again, these are like really, really new services. So the truth is that like it's so fresh that nobody's paying attention to this. Then they brought out their vectorized sort of database, which I haven't personally looked at. But if you're noticing, there's kind of a team here. There's sort of AI team that's sort of coming out in place. The hyperdrive. This is the one that I mentioned, is sort of to deal with this whole worker problem of like connecting to a database. There's a trend that you could see here. These guys from 2021 onward have clearly decided that they want to compete with the big guys. They've clearly made that decision. It's very, very clear from the announcements and the drive and the focus here. And what they're doing is they're in hyperdrive, trying to play catch. They're just hitting all cylinders, and you can see it in the way that they're delivering and the way that they're pushing out products. That is, they're just moving faster. They're really just getting started. Fast forward to April this year or last year, they brought out their browser API so that you could do browser stuff. They've upgraded again their workers API to deal with all the AI stuff and pricing and all this kind of stuff. And now we're in this browser rendering world. So you can clearly see that CloudFlare, the first early years is how I would describe him, as doing sort of like infrastructure work. And then AI revolution happened, and they jumped on the AI bandwagon and they started building out stuff for AI. And then they realized they needed a better database system, so they put out a database system to kind of deal with it. And here, from this point forward, they're really just filling in some of the basic blocks, and they're just cooking on all cylinders. The container technology is kind of one of the last layers. From here, it's doubling down on the AI revolution, and I guarantee you, with the requirements of AI and the speed, this is going to take off. No question about it. CloudFlare will take off in a way that people haven't seen before. And people are going to come back and watch this video and be like, how did you see this? It's just so obvious. Now, here's the thing, here's what I think is going to make CloudFlare just completely off the charts. Number one, obviously AI. I just said that before. Number two, voice. So I personally believe that voice is 100% the future based on what we've seen with these models. My work habit is changing how I interact with AI. It's changing how I interact with a computer. I'm typing less. I'm voice recording my typing and putting it into the computer with Whisper. And that is definitely a thing. In order for you to get voice right for any SaaS application, you need to get the latency down. If you're more than 300 milliseconds in terms of latency, human beings can tell the difference and they're like, forget it. With Cloudflare's edge network, that latency problem can be solved. And 100% certainty, there's going to be a lot more applications that are building voice, and they're just going to flood to Cloudflare. It's just that simple, because just purely by latency wins the game. By default, they will win that game. And as a result of that, that will force them to innovate faster on their AI solution. And I guarantee you, the startups will come. And when that happens, Cloudflare is going to be a very different sort of SaaS platform provider or cloud provider than what it looks like today. And I think they're just getting started in that. They recognize it. They're playing good with the ecosystem. They're basically pushing their technology out in the ecosystem. They're just getting the word out. I believe the same way that it took Evan You from like, let's say 2015 to like 2025, like a good 10-year run in order for the JavaScript ecosystem to kind of get caught up to what this guy was doing. I believe in the exact same way Cloudflare will win this game based on what I'm seeing, based on the trajectory. And that's the reason why I'm doubling down on just basically providing all my service and building my services on Cloudflare, because it's very clear to me. With that, let's wrap this thing up. Talk about some of the just sort of overall things about Cloudflare. Number one is the edge is going to change every single thing. It already has. It's just that Cloudflare is just going to do it better than the other providers. Okay. I don't care what you say about Vercel and ease of use of deployment and whatever. Vercel is not winning this game. I want to be clear with this. They're not winning this game by nature, just based on the fact that they're sitting on Azure. They're sitting on AWS, and their bills are never going to be cheaper than AWS bill. Period. On the startup side, sure, but that will only last for so long. The companies like Heroku that were winning this game before, they've gotten bought up by companies like Salesforce, and as a result, cheap pricing tiers have all disappeared, and now it's all about money. Cloudflare is in a perfect position where they have just enough primitive layer infrastructure that they could then basically put really innovative, cool technology on top that runs extremely light and efficient. I'm rambling, but I really, really believe this. Hopefully you've gotten that picture. Hopefully you've gotten sort of like at least a good understanding between their thing. I haven't even touched durable objects, which is this weird, super innovative cloud key value storage thingy that has web's connection to every single application that's using it in real time. It takes a while for you to wrap your brain around that. But my point is this: because of this sort of new way of doing things, it's going to take a lot of developers a little bit more time to wrap their brain around it. The ones that get it will. The ones that won't, it's because frankly they've just got stuck in their ways and they just don't want to change and admit. But if you can make that jump to Cloudflare for some of these things, you will win the game in so many things. That being said though, Azure still has its place, and I don't want to take away any single thing from Azure. I'm a diehard Azure fan for a lot of things. As I mentioned to you, I'm still using Cosmo DB. We're using Service Bus right now, but we're coming off of that. Container apps is the evolution of Kubernetes for dumb people. I like to describe it, aka me, because I have no interest in dealing with Kubernetes. Yeah, Azure Container Apps is really good. It has scale to 0, so it's really, really efficient. I've tested it. I've used it. I have it in production right now. There's some things I like about it. I'm kind of surprised about the pricing, because as an example, one of the servers that I currently have on containers right now, my calculation is that it was going to cost me like $10 a month, and I'm seeing numbers of like $30 and $40 per month, and I still haven't been able to figure out why. And that's partially because Azure charges for login, charges for a whole bunch of other stuff, and so that kind of creeps into your costs and you don't necessarily recognize it until it's late. That being said, container service, I will swear by it, it's actually a really good service. It's a solid service. We will not move from there anytime soon. In fact, we're doubling down on that, with one caveat, one exception. Cloudflare containers is significantly faster in terms of boot up time. In my testing so far, it's 5 seconds versus 40 seconds. So we're shifting some of our workloads even to containers, and pricing wise, they're about the same. So I'm okay with making that switch for faster performance. Flex consumption, really good, solid, rewritten from the ground up because of limitations in the previous Azure Functions implementation. And it's just rock solid right now. There's some missing features that it doesn't have, like slots, which I won't get into. So those are some things there that definitely need some work in the Azure side altogether. Going back to that layer diagram for a second, like I said, Cloudflare definitely wins when it comes to the security layer for sure. Their solutions are significantly better. Probably there's some caveats there, but it definitely is just a solid solution now. On the UI layer, as I said, with the global CB pages or workers layer, it's super solid. Their business logic tier, they're just getting started with it. I think their business logic tier will win on the AI front for startups. But when it comes to like traditional sort of business logic type stuff, definitely Azure still takes the win on that. For now, scheduling and sort of the storage layer, we talked about that, Azure win. So with that, the takeaway is this, and hopefully you've gotten some value. There's a lot of information here. If I did, put it in the chat and I'll make a separate video on it. I'll just leave you with this. Don't build your application because of hype. Think about the details. Think about the architecture. Think about your customers, think about costs of training your developers, and then decide from there which platform is the right thing. There is a learning curve with Cloudflare. I cannot stress that enough. It's a fundamentally different way of thinking about development, and that comes with a cognitive load that you have to shift, and not every developer will make that jump. So if you're getting ROI from Azure or AWS, stick with it. If your business can support the costs, by all means, run with it. Like, this is not a zero-sum game. You can have your foot in both worlds, and that's okay too. But at the end of the day, what I'll say is my goal is to simplify complexity. I started this video by showing you a whole bunch of complex stuff of how we just kept evolving, and the level of complexity just kept growing and growing, but we weren't necessarily reaping the gains, both from a performance and a scalability standpoint, in relation to costs and what we were getting from our customers' ROI. So I've been really pushing to scale back complexity, bring simpler systems on board, and reduce costs. And that's where Cloudflare wins all day long. Bringing things more to the edge for this AI first world that we're moving into just makes sense. Cloudflare wins. Like, obviously Azure has some solutions as well too, but just in terms of like low latency and the things that Cloudflare is doing, that they win that game for sure. Having sort of a hybrid cloud solution, it's definitely not a weakness, it's a strength. So with that, hopefully you've gotten some value out of this video. This has been a long video, and I hope that you could put some comments in the chat to give me some feedback on any single thing that I may or may not have done correctly. Have yourself a wonderful day, and I'll see you in another video.